Hi everyone, in this video I would like to continue with tokenization. So this is usually the first step of the training process. So the way it works is we start with a data set. You want to train this systems like GPT. Of course you need data, right? We start with data set. So for this example that I will be using, I will be using a very short small data set. So it could be kind of a text data like this. Let me write something random. Say NLP is good. Machine learning is good, and its continuation. So we start with a data set. Let me make this clear. This is NLP. NLP is good, machine learning is good, and the continuation. So we have a small data set here. Well, let me talk about pre-training in general. So in pre-training, what is usually done is for a given word, you try to predict the next word. For a given word, say is, you try to predict good. For a given word, you try to predict the next word. This is the pre-training. In general, of course, computers deal with numerical data. So we have to convert this data into a numerical form. So this is where tokenization comes in. For your information, we will be on a character level tokenization. So instead of, say, predicting the next word, given NLP try to predict ifs, we will be saying, okay, given N, we want to predict L. Given P, we want to predict space. So we're on character level. This is just to make things easy. So the first thing that I want to do is I want to write all the distinct characters in my data set. So starting with A, B, maybe there's letter A in some place, there's letter B, then C, and capital A, capital B, so capital B, all the way to Z. Maybe there's 1, there's 2, and maybe there's a dollar sign. So all the distinct characters in my data set, I'm going to write them in here. Alright, the next thing that I'm going to do is this data set, of course, this is a kind of a list with a length of 65, say 65. This is actually very important. So each of this character is going to have an index. So this is index 0, 1, 2, all the way to 65. Right? And this index is actually very important for the subsequent layers, for the embedded layer, which we'll be seeing later on. So then we will be converting this data set to a numerical form. Well, the way to do that, we already have this. We'll be using this. So for N, we'll look at the index in here. Maybe the index is 39. For L, the index is, say, 11. For P, the index is 15. For space, the index is 65, 63, and so on. Say 18 and 63, 6, 14, 14, say 3 and 63. So I'm just writing the index of all the characters in my data set. Now we have kind of taken the first step to converting the data from to a numerical form. All right, so I would like to discuss some parameters that are important. Number one is the batch size. So in machine learning, we will not be processing all of the data at the same time. We'll be fetching data in batches, and of course that is more efficient in terms of memory. Batch size. So for our batch size, we'll be using 2. So we'll be taking 2 batches. We'll see what that is. Another parameter is block size. Block size, that is also BS. Let's call it actually BL. Block size for us will be 4. This batch size and block size are really important parameters, and they can influence training in general. Like, they can influence how fast you are training the model. All right, the next parameter is device. Of course, we will not be using device because we're doing everything on a piece of paper, but the device is actually important. So when training on a computer, you can decide where to load this data. You can load the data on a GPU, CUDA. You can also load it on CPU. You can also load it on MPS. This is for Apple Silicon computers. And usually CUDA is really fast. And the last parameter that is also important is embedding size. Let's call it E. We will be using 4. This embedding size determines the kind of dimension of our embedding dictionary. I'm defining these parameters now, but especially this embedding size, but we will see it clearly in the next video. All right, so now we have converted the data set to a kind of numerical form. Let's see how we get X and Y. So to get X, let's see X. The X will depend on batch size and block size. So we can look at the data randomly and look at a kind of a window of 4. So starting from here, for example, to we move kind of 4 steps, we get this section. And since our batch size is 2, we will do that again. We can take this section starting from 63 to here, maybe to 14, since the block size is 4. This is totally random. You could have started from 6. Okay, so then our input X will be 11, 15, 63, 8, 63, this 63, 6, 14, and 14. Then Y will actually be X, but shifted to the right. So in here, instead of 11, we'll start at 15. So 15, 63, 63, 8, 18. The second one is 6, 14, 14, and 30. So this is X. This is the input to the model, and we will be trying to predict this Y. Notice that, of course, the dimension of this input is very important, because that kind of determines the dimension of the weight in the later later layers. So the dimension of X is batch size, of course, BS by block size, so 2 by 4. here is also 2 by 4. Okay, I think so far so good. So this X will then go to the embedding layer, which we are going to be seeing in the next video. Thank you very much. See you.